Do need to talk about phase diagrams very quickly. This is a map of the state or the phase of a substance as a function of pressure and temperature. So we graph pressure on the y-axis, temperature on the x-axis. And there are different regions which represent conditions under which that particular state is stable. So you can see in the liquid region, the liquid will be present with all these combinations of temperature and pressure. In between the regions are lines, they're actually curves. They tell us where a state transition is occurring. And so these are labeled the vaporization curve for where it's going from a liquid to a gas, sublimation curve, and fusion curve. The triple point is a crazy place where all three states are stable and at equilibrium. And I'll show you that video later. So here's a phase diagram for water. We've got pressure on the y-axis and temperature on the x-axis. This is the sublimation curve. And so this is telling us at this temperature, if I'm above this pressure, I'm going to have a solid. If I'm below that temperature, I'm going to have a liquid. So the solid is present in this region, liquid is present here, and a gas is present here. So room temperature is going to be about here, normal atmospheric pressure, and so water's a liquid at 1 atmosphere and room temperature. We cool down to 0 degrees Celsius and we see it freezing. We increase up to 100 degrees Celsius and we see it boiling. This is the critical point. Above the critical point, you can't have a liquid. You've just got a supercritical fluid. The triple point is this place where the three curves intersect, and that's where you have a solid, a liquid, and a gas all at the same time. So there can be questions asked about navigation within a phase diagram, and so you're either going to be changing temperature or changing pressure. So at 1 atmosphere, what happens as I heat it up? Well, here's 1 atmosphere going from minus 25 degrees Celsius. As I heat it up, it's going to melt, and then I've got a liquid increasing in temperature, and I get up here and it's going to boil. Or I can look at pressure changing at a given temperature. If I start here at atmospheric pressure and I reduce the pressure at room temperature, at some point it will boil. The water will boil at room temperature, and then it will continue, and I've got a gas. Different substances have different shaped phase diagrams. Water is kind of weird in that this fusion curve has a negative slope. That's not typical. Here we've got iodine and carbon dioxide, and we see this fusion curve has a positive slope for both of these. Carbon dioxide is weird because here's atmospheric pressure way down here. There's the solid. As you go out to higher temperatures, it goes directly to a gas. You cannot have a liquid at atmospheric pressure.